Good morning, one and all. I, Professor Niranjan Pattar, would like to extend a warm welcome to you all on behalf of KLE Dr. M.S. Sheshgiri College of Engineering and Technology, Belgavi, for the online ATAL FDP on augmented reality and virtual reality. It is a mark of our undying tradition to invoke Almighty at the beginning of an important event. Like the great philosopher once said, the function of a prayer is not to influence the God, but rather to change the nature of one who prays. Now, I would like to call upon Ms. Shreya Kurbet to pray for us. Over to Shreya.
गणनायकाय गणदैवताय गणाध्यक्षाय धीमहि गुणशरीराय गुणमण्डिताय गुणेशानाय धीमहि गुणातीताय गुणाधीशाय गुणप्रविष्टाय धीमहि एकदन्ताय वक्रतुण्डाय गौरी तनयाय धीमहि गजेशानाय भालचन्द्राय श्रीगणेशाय धीमहि गानचतुराय गानप्राणाय गानान्तरात्मने गानोत्सुकाय गानमत्ताय गानोत्सुखमनसे गुरुपूजिताय गुरुदैवताय गुरुकुलस्थायिने गुरुविक्रमाय गुह्यप्रवराय गुरवे गुणगुरवे गुरुदैत्यकलक्षेत्रे गुरुधर्म सदाराध्याय गुरुपुत्र परित्रात्रे गुरुपाखण्ड खण्डकाय गीतसाराय गीततत्त्वाय गीतगोत्राय धीमहि गूढगुल्फाय गन्धमत्ताय गोजयप्रदाय धीमहि गुणातीताय गुणाधीशाय गुणप्रविष्टाय धीमहि एकदन्ताय वक्रतुण्डाय गौरी तनयाय धीमहि गजेशानाय भालचन्द्राय श्रीगणेशाय धीमहि ग्रन्थगीताय ग्रन्थगेयाय ग्रन्थान्तरात्मने गीतलीनाय गीताश्रयाय गीतवाद्यपठवे ध्येयचरिताय गायगवराय गन्धर्व प्रीकृते गायगाधीन विग्रहाय गङ्गाजल प्रणयवते गौरीसनन्दनाय गौरीहृदयनन्दनाय गौरभानुसुताय गौरी गणेश्वराय गौरीप्रणयाय गौरीप्रवणाय गौरभावाय धीमहि गोसहस्राय गोवर्धनाय गोपगोपाय धीमहि गुणातीताय गुणाधीशाय गुणप्रविष्टाय धीमहि एकदन्ताय वक्रतुण्डाय गौरी तनयाय धीमहि गजेशानाय भालचन्द्राय श्रीगणेशाय धीमहि श्रीगणेशाय धीमहि श्रीगणेशाय धीमहि. Thank you.
Thank you, Shreya. Light fades away the darkness. Light symbolizes the knowledge and wisdom. We will have our traditional auspicious lamp lighting ceremony as a tribute to Mother Saraswati, the goddess of knowledge.
आरोग्यं धनसम्पदः शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः शत्रुबुद्धिविनाशाय दीपज्योतिर्नमोऽस्तुते दीपज्योतिर्नमोऽस्तुते शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः.
Thank you. Now I request Dr. C.V. Adike, HOD Mechanical, to welcome the gathering.
Good morning, everyone. It gives me immense pleasure in welcoming the dignitaries and the participants to this FDP sponsored by AICTE Teaching and Learning Academy. First of all, I welcome keynote speaker Dr. K.P. Karnakaran, Professor Chair, Mechanical Engineering Department, IIT Bombay. I welcome you, sir. I welcome President of today's function, our beloved Principal, Dr. Basavaraj Katagiri, to this FDP. Welcome, sir. I welcome Dr. Praveen Korpade, Dean Academic, Dr. R.V. Riker, Dean R&D, Dr. S.F. Patil, Dean Student Welfare, and Dr. U.B. Deshinawar, Dean Affiliation, to this inaugural function. I welcome heads of various departments and faculty to this function. I welcome all the participants and faculty of various affiliated colleges to this FDP. I hope this FDP will definitely help to improve the knowledge and skills on augmented reality and virtual reality. Thank you again. Thank you, one and all.
Thank you, sir. Now I request Dr. S.I. Sanwadi, Coordinator ATAL FDP, Professor, Department of Mechanical Engineering, to brief an objectives and overview of our FDP.
Keynote speaker, Professor K.P. Karnakaran, Institute Chair, Professor, IIT Bombay, President of this inaugural function, our beloved Principal, Dr. Basavaraj Katagiri, renowned resource persons, deans, heads of department, participants, ladies and gentlemen. Ladies and gentlemen, initially the objectives of this FDP when we submitted our proposal was to introduce the Faculty of Mechanical Engineering to augmented reality, virtual reality, and mixed reality, and discussing various use cases. Also to deliberate on applications of AR and VR to education, manufacturing, automotive, aerospace, training, and industry. Designing the content of AR and VR. With the passage of time, what happened was we found that 95% of the participants who had registered for this FDP were from computer science and electronics and communication. So the objectives had to be modified to have a hands-on usage of Neon XR on desktop and mobile using advanced mode and easy to understand and implement XR platform, lessons on and playlist to train the audience on lesson applications, collaborator, assigning lessons to students, to equip faculty with lesson creation, UON XR, 3D and 360 degrees, to engage the audience on an experience in designing, developing, and deploying experiential learning tools and its usage during the pandemic, to showcase a vertical project, to have a hands-on experience on Google Cardboard. Ladies and gentlemen, augmented reality is more recent technology than virtual reality and shows an interdisciplinary approach framework in which nowadays education learning seem to be the most important field of research. Indeed, AR allows supporting learning, for example, increasing on content, understanding, and memory preservation, as well as on learning motivation. However, if VR benefits from clear and more definite fields of application research areas, AR is still emerging in the scientific scenario. In the last 5 years, virtual reality and augmented reality have attracted the interest of investors and the general public, especially after Mark Zuckerberg bought Oculus for $2 billion. Currently, many other companies such as Sony, Samsung, HTC, and Google are making huge investments in VR and AR. However, if VR has been used in research for more than 25 years, and now there are more than 1,000 papers and many researchers in the field comprising of strong interdisciplinary community. AR has more recent application history. The study of VR has initiated in the computer graphics field and has been extended to several disciplines. Currently, video games supported by VR tools are more popular in the past, and they present valuable work-related tools for neurosciences, psychologists, automotive, manufacturing, aerospace, biologists, and other researchers as well. Indeed, for example, one of the main research purposes lies from the navigation studies that include complex experiments that could be done in laboratory by using virtual reality, whereas without virtual reality, researchers would have to go directly into the field, possibly with limited use of intervention. The importance of navigation studies for the functional understanding of human memory in dementia has been a topic of significant interest for a long time. And in 2014, the Nobel Prize in Physiology or Medicine was awarded to John Caffey, May Brett Moser, and Edward Moser for their discoveries of nerve cells in the brain that enable a sense of place and navigation. Journals and magazines have extended this knowledge by writing about the brain GPS, which gives a clear idea of the whole mechanism of AR and VR. We wish that this topic of augmented reality and virtual reality and its application form a major part of all the participants' research canvas. Thank you, ladies and gentlemen.
Thank you, sir. Now I request our beloved principal, Dr. Basavaraj Katgeri, sir, to give the presidential remarks.
Thank you, Niranjan. Am I audible?
Yes, sir.
Yes, sir.
Keynote speaker, Professor K.P. Karnakaran of IIT Bombay, deans of this college, heads of the department, Professor Chandrasekhar Adike, head of mechanical department, Professor Sunil Sangoli, coordinator of this ATAL program, FDP program, all the staff, participating staff from various colleges across India, resource persons, press and media, a very good morning to one and all. At the outset, I deem it a great pleasure to extend my hearty congratulations to Mechanical Department, headed by Professor Adike, and the coordinator, Professor Sunil Sangoli, and the whole team of Mechanical Department for having taken up this initiative of conducting AICT-sponsored ATAL FDP on augmented reality and virtual reality and its applications. As already explained by the coordinator, Professor Sangoli, these days, augmented reality and the virtual reality and its applications, mainly in mechanical domain and other allied branches, he has explained enough. I would not like to take much time because let's hear to the keynote speaker. However, I get to understand that this program will expose the participants to the tools and methods to create their own world using VR and bring virtual objects to real world using AR. Experts, I also understand that experts will demonstrate their products and give a walkthrough various development stages of AR and VR applications. This program will pave a path to understand and apply the principles of AR and VR to real-time scenarios. Addressing the above problems, this FDP is being organized for the faculty who are pursuing research in the above areas from various AICT approved engineering colleges across India. We too have resource persons from IIC Bangalore, IITs, NITs, and other reputed premier institutes and industries. They would be delivering lectures and imparting hands-on sessions on various areas of augmented reality and virtual reality. I once again thank Professor Karnakaran for having accepted our invitation to be the keynote speaker. Sir, thank you very much for taking out your time and being part of our program. This will really give a lot of motivation to all our staff who are working in this area, mainly the research descent. I am sure you'll all be benefited by the keynote address of Professor Karnakaran. With these words, let me close my presidential address here and give enough time for the next topics and other deliberations to go on. Thank you very much and all the best. Happy learning for next 5 days. Thank you, Niranjan. I am done with. Thank you.
Thank you, sir. Now it's time to give the vote of thanks. I, on behalf of the management, principal, and entire fraternity of the college, first of all, I extend my sincere thanks to AICT Training and Learning Academy for providing a financial support in organizing this 1-week online FDP on augmented reality and virtual reality. I would like to express my sincere thanks to Principal Dr. Basavaraj Katgeri to encourage and guide us CV Adke for guidance and moral support in conducting this FDP. I express my gratitude to all the speakers from the various industry and reputed institutes such as IITs and NITs for accepting to share their knowledge in this FDP. I thank I, I all the participants for selecting and attending this FDP. I also thank press for your support. I thank all the deans, HODs of various departments, and staffs and students for their support in organizing this FDP. Final vote of thanks to all the people for directly or indirectly event successful. Thank you, one and all. Uh, Before we move to the next session, I would like to call all the participants to come in a video mode so that we can have one group pic. So kindly, I request all the participants to come in the video mode.
Yes, sir. Thank you. We are done with it.
Thank you, Sai sir. Thank you all the participants. Now I request Dr. S.I. Sangoli sir to introduce the keynote speaker, Dr. Karunakaran KP.
Good morning, ladies and gentlemen. President of this FDP, our beloved Principal Dr. Baswaraj Katkeri, renowned resource persons, deans of our college, heads of department, participants, ladies and gentlemen. It gives me great pleasure to introduce a renowned professor like KP Karunakaran, who is presently an institute chair professor in the Department of Mechanical Engineering of the Indian Institute of Technology, Bombay. He has 16 years of professional experience. He has 36 years of professional experience. He worked as a CNC programmer in Hindustan Aeronautics Limited for almost a decade since his graduation in 1984. He's been teaching and researching in IIT Bombay since 1994 in the areas of manufacturing automation, which includes CNC technology and rapid manufacturing. He launched Optil a preprocessor for LOMRP in collaboration with Daimler Chrysler and materialized in Euromold 2002. His research focuses on the synergic integration of hybrid processes and multiple technologies to complement the competing options and execute multiple operations under a single platform. His hybrid layered manufacturing has four kinds of hybridization, like material addition, subtraction, different energy sources, slicing strategies, and kinematics. Having consumed close to 2 decades and rupees 160 million, their multi-station, multi-axis HLM is under fabrication for commercialization. Segmented object manufacturing is similar one from 3D printing. This has been evolved over 2 decades with an expenditure of rupees 10 million. A rapid foam SOM patterns he has developed, foundry being set up at a cost of rupees 50 million through the help of MHRD UAY 2016 project will use the SOM patterns. He has developed a scan 3D printer for cores and molds through another UAE 2016 project with an outlay of rupees 50 million. He is currently developing two electron beam additives manufacturing processes with a total outlay of rupees 110 million. One using powder bed technology and the other using wire cladding. That 25% of these projects is contributed in cash by the industry partners highlights their relevance. His promise is to launch products to 10th of their imported price, 1/10 of their imported price through Indianization and innovation. Helicopters without tail and drones are his great passion. His manned drone defied gravity on November 20, 2020, and he too has lifted along with it on November 28, 2020. It was for the noble application of safe, rapid, and affordable transport of donated organs. The endurance of its present battery version will be enhanced through other versions powered by genset piston, genset turbines, and hydrogen fuel cells. Apart from tethered version, Hyundai has agreed to donate an hydrogen fuel cells. Its half-scale UAV has been successfully flown autonomously. Each of these variants will have its own interesting, unique applications. The manned drone defied gravity on November 2020 without a man sitting on it, of course, and it lifted slightly on 28 November 2020 with him tied to it like a patient in an ambulance. His anxieties and uncertainties about his capable in building such a big bird are already over, but still more work is left. But this success gives him more energy too. There's a lot of work before it is deployed for the intended application, but the team are more confident now. As far as he knows, this is the largest drone ever built in India. Infrastructure was fabricated out of SS tubes, stainless steel tubes of 10 mm square, 0.9 thick, which is the main unique selling proposal of the department. The cost of bill of materials is under 15 lakhs. Presently, it is powered by battery. In order to get high endurance, they are considering genset piston, genset turbines, hydrogen fuel cells. Tethered flight will also have immerse applications. Finally, all these 5 versions, each finding its own application. Sir was a consultant with the renowned Mercedes-Benz Technology Center in summer 2000 and Vicom Taiwan, St. Sebastian, Spain in 2000. He has been associated with Fraunhofer Institute in Stuttgart. He has been visiting professor in the University of Metz, France, Ecolo Central D. Norris, France, Mondragon University, Spain, Cranfield University, UK, and Peron National Research Polytechnic University, Russia. Ladies and gentlemen, may I present to you Professor K.P. Karnakaran, Institute Chair and keynote speaker of this August gathering. Thank you, ladies and gentlemen.
Thank you, sir. Now I request Dr. K.P. Karnakaran sir to take over the online session and deliver the lecture.
So thank you very much. How much time do you give me? 90 minutes? 90? How much is the time allotted?
90 minutes, 90 minutes, sir.
Okay, okay. So thank you very much to Dr. Sunil, Professor Pasaraj and others for inviting me for this event. I'm sorry, Dr. Sunil, for a very long introductory note about me. Next time I'll do a little more precise writing. It is a little bit embarrassing to too long, and I'll do a little homework and come back to you. Okay. So once again, thank you very much. Very good morning to all of you. This is also the right time for the theme of this particular event, augmented reality and virtual reality. I think we don't need the two terms, augmented reality alone is enough, because I think virtual reality is a subset of that. And today in the COVID environment, we say it is blessing in disguise, although, a lot of loss financially has taken place. When Sanishwar Bhagwan catches us, when he leaves, he creates a lot of damage, but when he leaves some good things to us. In the same way, COVID has blessed us. It taught us how to make use of this media. Today we are holding events like this in a virtual way. The travel has come down in a big way. The expenses have come down in a big way. A lot of activities and interactions happen over the video mode. It also has told us how bad is the bandwidth we have. It will be nice, in over a period of time, the bandwidth improves and we are all able to see each other with video, because you'll find that as things progress, when everyone switches on the video, then the communication becomes bad. So all that will slowly improve, and we should thank COVID for pointing out these lacuna, and then allowing us to work in a virtual mode. A lot of IT companies are now working from home. Of course, automotive companies cannot work from home, but certainly the IT companies have learned. I think they're going to shut up a lot of their real estate investments. So there are a lot of good things happening in spite of a huge loss and time we all have suffered. Anyway, apart from that, I have visited, I really miss Belgaum. I have visited Belgaum several times. I visited the Foundry Cluster. I visited Gopte College. I visited the university. I've been visiting Belgaum for almost 15 years. So I'll look forward to the opportunity for a physical visit to your college next very soon. Now I'll go for the sharing mode. I'm actually proposing, wait a minute, share. Okay, stop share. Let me try again. I have to share everything. Advanced. Virtual portion of content.
Sir, kindly.
I want to completely share. So let me see. Let me share this screen. I think that should be fine.
Yes, sir, it is visible.
Are you able to see my PPT now?
Yes.
Yes, sir.
Yes,
Okay. So, Dr. Sunil, when only my PPT is visible, because on my screen, some of you are also visible. I will minimize that.
Yes, sir.
Okay, I think that should be fine. I hope only PPT is visible. So I want to make a presentation in two parts. For the first 20 to 25 minutes, let me talk about my areas of research, because I look at the events like this, not really for a huge jump in knowledge, but the benefits are to know each other. I will know you and you will know me. Similarly, you will also know other resource persons, and they will know you, because this bidirectional introduction of each other will go on for a long way. This is what we call it as networking. So this networking is something I value as much as the knowledge you gain in this particular program. So make sure that you are able to note down the addresses, and I'm trying to minimize this fellow.
Sir, use hide thumbnail. Sir, use hide thumbnail there. On top, there are 4 options. Grid, then thumbnail.
Oh, I'm okay. Hide floating. I think that's fine. Yeah. I think it's okay. But my slide is okay, right?
Yes, sir.
Okay.
Yes.
So I worked in HAL during 1984 to 92, because flying has been my passion since the beginning, like anybody else. But interest is slightly different from passion, but I could not resume it. Although I joined HAL, I ended up as a manufacturing engineer. I never did anything on aerodynamics or structures, but I ended up as a manufacturing engineer. Then I did PhD in IIT Kanpur on CNC technology. Then till about 2005, I was focusing only on manufacturing engineer to stabilize myself. And then in 2005, I resumed my interest in flying activities. Now, flying is not me flying. I wanted to develop these products. I am the earliest or one of the earliest in India to develop drones. Our drone was demonstrated in 2007 in Agra. We had funding of about 10 lakhs in this particular project. Subsequently, a lot of people worked on it. In those days, it was an emerging technology where we needed propellers which had opposite pitches. So these were not readily available. Either they were right hand or left hand. They call it as pusher or puller. So we fabricated it out of our 3D printer and then used it. So the figure you see here is our earliest drone in 2006 or so. After that, we migrated to manned drones and helicopters. I was working on it for a long time, but there was not much of success. And then I think a video is running. You're able to see a video. This is our first drone, which was tested on 20th of November. You see that it has a single frame. The entire frame was made out of stainless steel tubing, 10 millimeter by 10 millimeter with 0.9 to 1 mm wall thickness. This is our RM lab. So each motor, it uses 8 motors, so 8.5 kilowatt each. So totally about 68 kilowatt power it used to consume. So the structure weighed about 68 kg and the total thing weighed, including me, about 250 kg. So finally it took off. This is empty takeoff. So it is a wild horse, first time flight, so he is trying to control it. So don't worry about the altitude. During initial test, you don't fly very high. We limit to less than a meter. Then subsequently, on a week later, after getting used to it a little more, this is me without beard. So I was tied to it like an ambulance, like a passenger in an ambulance. So we find that this type of application is very ideal to behave as an ambulance. Unfortunately, it was too heavy to lift off. So few inches it lifted for few seconds. Then we gave up. Only this much it was possible. Then we discarded this structure, went through 2 structures. Finally, before coming here on 27th, on 17th of February, we succeeded in it. You'll see this is a totally different and interesting configuration. So see, this has 2 frames. It's like 2 quadcopters connected with each other. So 2 independent quadcopters connected with each other. So this took off comfortably, empty weight. Then I sat on it. I was also lifted comfortably. So this is the first time in India a drone was able to carry a human being. Here again, we limited the height to less than 2 feet because we need to focus on safety first. But once it lifts off, then the height or duration is a matter of time and further proving. This gives the confidence and proof that it is possible. As I said, our USP is a welded structure. The structure you see here weighed 34 kilo, costed us only 60,000. It's phenomenally cheap, more than a tenth cheaper. So
Thank you. See you.
So we are now more confident than before that it will work. The whole product is costing less than 12 lakh, and the immediate application we see is, it's possible to easily make it fly for about 40 minutes with battery power, and it can fly for 30 to 40 kilometers. So for urban application as an ambulance, this can be done. If I don't believe in unmanned flight yet for serious applications like transporting a human organ or transporting a patient, because the landing is still an issue. We are not talking about transporting pizza or a letter pack, but we are talking about a livestock. So I still believe that we are far away in terms of landing. I'm confident of takeoff and cruising and collision avoidance, but certainly not for landing. So we are focusing on manned type, and this same thing can be easily expanded even with battery power. Simply add more batteries. The duration will remain the same, endurance will remain the same, but size can be anything. Endurance in terms of distance and time will be limited to 30 to 40 minutes, but the payload can increase to any extent. Therefore, you will also see the configuration, which is very ideal. The central long bay can become the patient's area, and on the left and right, we can have pilot as well as a caretaker or like a nurse or a doctor. So it can easily become an urban ambulance for quickly transporting people. And in my opinion, we will be able to make it within a cost of 20 lakhs. Of course, when somebody takes it over and sells it, he may probably sell it to 30 lakhs, which is still comparable to the ambulance that runs on the ground. So this is the kind of ambition we have. The next ambition is to replace the battery with petrol engine driven alternator, which will produce the required electricity. That means depending on the amount of petrol we carry, the endurance can increase. But then you realize that for flying for about 1 hour, you need about 40 kg of petrol. So about 120, 130 kilometers of endurance coverage is possible with one refill. So if you want a larger coverage, then longer coverage, you need to do refueling. So we'll make it with respect to the a conventional fuel so that anywhere you can get down and then refuel. So that is the goal for transporting donated hearts between long distances like 250 to 300 kilometers, because a heart has to be transported within 4 to 6 hours of duration. By then it gets spoiled. So this is the goal. We want to avoid the green corridors and the costly airlifting using helicopter or planes. We want to use this type of drone, which will be less than about, with petrol engine, I see that it cannot cost more than 40 lakhs. So that's a kind of ambition we have. So we also developed, whatever we develop, we first make a scaled version. So this is the scaled version of the drone that you saw flying. It was made out of the same pipe, while the larger one was a truss type of arrangement. Here we used one rod for each and then hollowed it by laser cutting. It's the same rod of 10 millimeter square, but we hollowed it with laser cutting. So this was tested. Then after we were happy with that, we are able to make the full one. Okay, so that is about my ambition for the drone side. I'll quickly spend a little more time on my projects in additive manufacturing. So what you see in this figure, we call it as hybrid layered manufacturing, or you can say hybrid additive manufacturing. We say hybrid because we are adding and subtracting material. So what you see here is a milling machine. This is a custom designed milling machine. It is under fabrication currently in Bangalore. So this is the latest photograph of it. You see that it is like two CNC machines facing each other. Okay, this is one machine, this is the other. And they together carry a long beam. This beam can be mounted with several tool posts as it is shown in this figure. So in each of the tools, we will be able to mount, each of the posts will be able to mount different tools. We can have a laser cladding system, we can have a MIG cladding system, TIG cladding system, we can have a preheating system, we can have a hammering system for stress relieving, we can put a camera to look at the quality like that. We can think of several tools to come up with the, because a layer requires a lot of things. When you especially deal with metallic objects, the amount of heat involved is so much, the stresses become too much. That leads to warpage or cracks. So therefore, we would like to have multiple tools to create a layer. The layer should be preheated so that the amount of, the chance of residual stress are reduced. Then you do the cladding. While cladding also, the boundary we would like to clad in 5 axis using laser cladding, and the interior we would do with 3 axis in rasters using the MIG cladding system. That means we will combine not only material addition and subtraction. In material addition also, we will use different energy sources like laser and arc. And as you see in this particular figure, while see the first left 3 figures, bottom left figures, I'll change the pointer. So this is the CAD model, this is the piece we produced. Now you see it is highly twisted, and in 3D printing there's something called support mechanism. In our case, there's no possibility of support mechanism. So we tilt the substrate. Now you see that we are also using 3-axis and 5-axis kinematics. So kinematically also it becomes hybrids. In terms of slicing concept, the same impeller, we divide into 2 parts. The central core is a simple geometry. It can be built in 3 axes. Whereas the blade on it, so this is one type of idea, this is the other one. Here it is a traditional horizontal layered manufacturing, whereas here the central part is built in horizontal layers. Once it is ready, On top of it, we make use of 5-axis cladding to build the layers. So that means we are also, combining different kinematics and different layering concept. That way we have 4 levels of hybridization, and then we have multiple tools for heating, hammering, inspection and all. So we have gone for a custom built machine. This is the culmination of my research over the last 23 years into a commercializable product. We have spent in this project over till today. Okay, so then we also developed a machine for thermocol. This is the thermocol piece we add to it, and then from the CAD model, it will automatically produce that. So this is a very interesting machine. We have also set up a foundry which will convert the thermocol into metallic casting. Of late, all my projects are funded substantially by private companies. I have currently 4 projects of each 5 crore running, in which private companies put in 25% of the money in cash. Government gives the rest of it. So this is one machine of that type, thermocol conversion into metallic casting, which is known as rapid foam foundry. People in Belgaum will find this project interesting. Same with the next project also. In the next project, we have built a 3D printer for sand. The sand, which is already a coated sand, phenolic coating is there in the sand particles. So we spread a layer of sand, and a laser comes and then writes on it. So then the sand gets sintered. So this is the sand mold we created, and from which this part was produced. Now you see that it's a game changer, because sand casting is known for its poor quality. But the poor quality comes mainly because the mold is in multiple pieces. You have wooden pattern which has drafting allowances, and there are material allowances. So many allowances, the flashes come, the molds don't close properly, there could be offset, the solidification may not happen the way you want. So all that leads to very poor quality, but sand casting is the cheapest. So by going for 3D printing of the sand mold, we can reduce the number of pieces. Theoretically, it can become a single mold. Then all the allowances like allowances and flashes will go away. So you get very accurate part. So these 2 projects will be of interest to Foundry. Recently, we have succeeded in building a machine for 3D printing of ice. So you see the parts at both ends of this figure. These were recently, very recently, they were printed. I have a PhD student working on it. This is not yet funded, of course. Now, some years ago, we used the help of refrigerator to produce this particular geometry using a silicon rubber mold. Then we transferred that geometry into plaster of Paris and then produced this casting. Now, when you have ice as a pattern, if you pour plaster of Paris slurry, definitely it will not absorb the geometry because they are at different temperatures. So rather than ice transferring geometry to the plaster of Paris slurry, it will take a heat from the slurry and then start melting. So we found out another way of doing it. We are actually patenting it. We adopt a method of sublimation. So you quickly pour it, put it inside the freezer and apply vacuum. Then you get sublimated, the ice inside sublimates and evaporates. You are left with a beautiful mold. So this was actually produced like that. Then we also have 2 interesting projects. Having worked with laser, we have in this particular machine, we are going to mount a laser, which is a wire cladding system using a 4 kilowatt laser. We also use for this sand 3D printing laser. So we started with 130 watt laser. We have also ordered a 4 kilowatt laser. We are using CO2 laser for this, and for metal we use fiber laser. Not really fiber laser, so a semiconductor laser. But conveying is with fiber. So looking at these two energy sources, we realize that electron beam has some unique properties. So we are developing two electron beam based additive manufacturing processes now. The first one is about 5 crore and the second one is about 6 crore. So totally about 11 crore funding is available. The first one, 25% is contributed by a Bangalore company, and the second one, 25% comes from L&T in Mumbai. So we are quite active in additive manufacturing, particularly for metals, both for direct routes like HLM and indirect routes like various foundry methods. So that is briefly about a preamble of my research areas. So if you have any questions, note it down. We will discuss it at the end of it. So based on this preamble, now let me get back to the topic of today's interest. So I'm planning to continue till 11:45. I think that's okay. So the topic I have chosen is virtual and augmented reality. So as I told you people, probably the word augmented reality alone is good enough. I would like to impress upon you that this is really not my research area of interest, but I do some teaching to my students. So my material may not be very much up to date, but that is only to give the basic principles of the technology to all of you. So this is how I have organized my presentation. I'll define what people mean by virtual reality. Then what are the various features of a virtual reality by which we call it as virtual reality? Then what are the various technologies we will need to build a virtual or augmented reality system? Then I'll explain quickly what is augmented reality before conclusion. So this is how I have planned it. I'm going to give only a tip of the iceberg, and whatever I know a little bit about this technology, I'm very sure that there will be a series of speakers who are going to talk more, and they're going to give product-based demonstrations also. So, yeah. Now, I'm going to give the definition of virtual reality by some of the great people who invented this technology in the early years, way back in 1960s. So you will find that two words are extremely important when we talk about virtual reality. One is inclusion, other is immersion. Both mean almost the same. Okay, so we have to have all features and the related technologies to achieve immersion or inclusion. Okay, I'll quickly read these three definitions. The primary defining characteristic of VR is inclusion. Being surrounded by an environment, VR places the participant inside information. So when you sit in front of a CAD system, you know clearly that you are not part of the system. You are standing outside. Okay. Suppose you want to experience how it will be like inside a furnace. Okay. So standing outside the furnace, looking at the temperature of the furnace, looking at the pressure of the furnace, looking at it with IR camera, that is not inclusion. You are reading the data, you are looking at the camera views. How it will be like sitting inside, or the way I was flying the drone, how it will be like sitting in the drone and then flying it. So that is what we mean by inclusion. The primary defining characteristic of VR is inclusion inside the environment. You are not going to look at the environment through a window. You are going to see through it. You are going to be inside it. So now the same statement in a different phrasing, it says, indeed, in the ultimate display, one will not look at that world through a window, but will be immersed in it. Okay, so look at our traditional CAD system. You want to make a bracket or something, then this is a rectangular screen through which you are looking at it, you are interacting with that with the mouse and all that. So clearly that you are outside, and then you are looking at it through a window or terminal. Okay, so this is the definition from Ivan Sutherland, who is one of the well-known authorities in computer graphics and virtual reality. Now, the last definition is very crisp and it tells a feeling of it. It says, if I turn my head and nothing happens, it is not VR. It's a very simple definition. You look at your computer screen, you walk from one end to the other, your head position changes, but the scenery you see on the screen remains the same. At best, you may get a perspective nature of it, okay? But the information is the same. If the left ear of the person is visible on the screen, whatever be the position you go, it will be only the left ear, okay? In a true VR system, when you move around an object, you should be able to see the other parts of the object. So if I turn my head and nothing happens, it is not VR. So this is what the definition from a NASA expert. So I think it gives some feeling that these two words are important. You should feel part of the environment, then you get a feeling of immersion. Okay, so to get the feeling of immersion, you should be included in the environment. Okay, so immersion is the ultimate requirement to have a VR system. Now, immersion may not require all the technology or all the features of a VR I'm going to describe. I'm going to give 4 requirements of a VR system. Many times, even without the 4, you will be able to get immersed. It all depends on how cooperative is the experiencing guide. Okay, so let's say somebody is trying to hypnotize you and then you resist the hypnotizer. You will be able to resist, then he will not be able to do anything on you. Okay, so it all depends on how amenable you are, how cooperative you are for the activity to take place. So I give the example of a hypnotics. Even when you read a novel, you know, as you start reading more and more, then you get immersed into it. Then you don't feel like doing anything. You don't stop till you finish the last page of the novel. Same happens with movies. In movies, when we start, we know that these are all pixels on the screen. But as you start, as the movie unfolds, then you realize that you become part of it. You assume yourself, the men will assume as hero, the women will assume as heroine, and then they become part of it. So that is why you see that you know, people even weep during a movie show or a TV show. That is nothing but immersion. So this is the thing I'm going to insist on. All the VR, AR technologies have to focus on achieving immersion. Otherwise, you know, the purpose is not served. And immersion doesn't need the extreme technology. Immersion is possible if the user is cooperative enough. Okay. So now I'm giving a concise definition from my side. I would like to define VR as a more sophisticated, real-time, multimodal simulation. So I'm using 2 important terms, real-time and multimodal. By real-time, we all know it should happen instantaneously. There should not be any lag. If I move the mouse, the cursor should move immediately. It should not take 10 seconds to move. That's what we mean by real time. There's nothing called real time, but nearly real time. That means minimum possible lag. The second important aspect is multimodal. Okay, all our CAD CAM CAE systems use only sense of vision. No CAD system, whether it is FEA or solid modeling, makes use of any other sense. Everything is related to only sense of vision. Okay, so if we start using more and more senses, then our experience will become more and more realistic. Then without even making a prototype, you will be able to launch the product. Okay, so these are multimodal senses. Virtual reality attempts to incorporate more senses into the system. So it involves modeling an environment, presenting it to the user, and permitting him to interact with it intuitively and effortlessly. These words I have highlighted in red color. They are important because the environment that we are going to experience, it either doesn't exist, as in the case of an architecture. The building doesn't exist, or the bridge doesn't exist, or the airport doesn't exist, and then you model it completely. There could be another situation where the environment exists, but it's not accessible to you. For example, you want to bomb an enemy territory, a target. The target is very much there, but it's not accessible to you. So you try to model the target by doing a reconnaissance flight, capture it. So there are two possibilities. Either the environment is non-existent and you are creating, or it exists but not accessible. In either case, you need to adopt methods of creating the environment. After creating the environment, you have to present the environment to the user, and you have to allow him to interact with the environment. Then only the feeling of immersion will come. I'll explain a little more about these. So modeling is required, presenting is required, permitting him to interact with the environment is required, and such an interaction should take place intuitively and effortlessly. This is again very important. So all these definitions will become clear as we go along, because there are 4 important features I'm going to list which will lead to these achievements. So if you do all that, then we will get the feeling of immersion. So now I'll list quickly the various features of VR. Professor Sunil is going well. Audio visual is fine.
Yes, sir.
Okay.
Yes,
Okay.
sir.
Thank you. Thank you. Okay, so this slide basically shows the 4 important features of VR, in my opinion, which lead to the feeling of immersion. So ultimate goal is to get the feeling of immersion. So the 5th one I can add is the user who is interacting should also be cooperative. Okay, so the first one is real-time response. That means whenever you interact with it, immediately a response should happen, real time, with minimum possible lag. Then it should be photorealistic stereo rendering. Today, even in normal activities, we have photorealistic rendering. Your mobile camera is able to get you beautiful photorealistic rendering. But here what we talk about is stereo rendering. Now, I put one more word along this to stereo, 3D. Okay, today 3D displays are not very popular. They are still at laboratory level. What we have today commonly is the stereo vision. So we are going to spend some time on the stereo vision, how it is achieved. The third important thing is intuitive or spontaneous or effortless interaction. Okay, so you need to interact with the system. You cannot use a traditional mouse and keyboard to interact with that. It should be very intuitive. Okay, so I'll come to that again a little later. Finally, multimodal interaction. Here we are talking about adding more senses, apart from the sense of vision, which is by default there in all CAD, CAM, CA systems. We need to add sense of sound, sense of touch, sense of smell, sense of taste, all these 4. And we also talk about other senses that human beings are blessed with, and apparently the animals are not, which I beg to differ, but that's a matter of discussion. So these 4 are certainly required, which will help us in getting the feeling of immersion. But please remember that it is not necessary to have all of them at the best possible way. Okay, so let me quickly repeat again: real-time response, stereo or 3D rendering so that you visualize in 3D, then spontaneous interaction with the system, then multiple senses to be added to it. Okay, so now coming to real-time response, as I said, it should be without much delay. Now, please remember that the screen that we have in front of us is refreshed something like 25 times to even much higher than that. So that means all the pixels are rewritten that many times per second. Now, very often we need to create in a VR system images separately for left eye, image separately for right eye. In other words, if you want to really have a 3D view of an object, two eyes are required. With one eye, it will not be able to sense 3D. So that is called depth cueing. So both the eyes look at the same object, but with slightly different perspective. And the brain assimilates by doing a lot of computation, and then it visualizes it as a three-dimensional object. So that means we also have to put two different cameras and look at the object and then combine it into 3D and then send it to the eyes. Okay, so all that has to happen so fast. You know the number of pixels on the screen. You know that you have to refresh 25 times. That means for two eyes, it has to be 50 times refresh. So you can visualize what kind of computation goes into that. Okay, so much of computation has to take place within a matter of, I'll just address. Sudhanshu, I'm in a lecture. I'll call after 12 o'clock. Okay, bye. So we have to, this just to highlight the kind of complication involved in achieving this. So how do they do it? You have to make a lot of compromises in quality, because I'm making a statement here. This is a very common statement I tell to my students. Being the first or the first few is more important than being the best. Very often, in order to become the best, we keep on, procrastinating. We all know that perfection is not possible. So we should try to move towards perfection, but we should stop at some point, because it is impossible to reach perfection. It's a mirage. At some point, you have to stop and launch the product. You can't keep on improving the product and then take thousands of years, because we all have limited lifetime. So same here also. You see this particular cursor on the screen, the cursor, I'm sorry, cursor. The cursor is a typical example of a compromise. See the number of pixels the cursor is defined with. It may be hardly 15 or 20 pixels, because it has to move very fast. The cursor, when you move from one end to the other, the computation happens that fast, that many times it is refreshed. Therefore, people go for very simple, iconic cursors. Okay, so same thing. You have to make a lot of compromises, a lot of innovative tools to do the computation. So I'll quickly list 3 or 4 techniques for doing it. For example, you want to see whether two objects in the environment are intersecting or not. So you don't really take 2 CAD models of the object and then try to check whether they intersect or not. Instead, you first define the bounding boxes, okay, and check whether these bounding boxes interfere or not. That computation takes place very fast. Okay, so if the bounding boxes do not interfere, then you can 100% be sure that the objects also don't interfere. But if the bounding boxes interfere, then there is some possibility that the objects can interfere. So first you do bounding box check. If they don't interfere, then declare that they don't interfere. Otherwise, go for detailed computation. So similarly, you can think of bounding sphere checks, bounding box checks, or convex hull checks. So I'm listing here 3: bounding box, bounding sphere, convex hull. These are some simple concepts we will use to do the computation fast. Similarly, when you define an object in a CAD system, you may use freeform surfaces, you may use very smooth surfaces, but we degenerate the smoothness into polyhedral approximations. Typically, triangular polyhedral approximation is used. That again is a technique used to speed up your computation. when you talk about a geometry, it also has a topology. In a CAD system, it has two information. One is the basic geometric definition. The other is a topological information. Topological information says how the objects are connected with one another. So in VR, many times we are happy with set of triangles and we ignore the topological information to make things faster. Okay, I'll quickly show some pictures. You see here a very smooth object I discussed about. Now this object can be divided into triangles. Okay, so by dividing it into triangles, you are bringing down the computational efforts of graphic cards, which can do millions of triangle processing every second. So triangle-based approximation of object is one, and even the triangulation, you can decide your precision of tessellation. You see two objects, one has higher precision, the other has a lower precision. So when you look at an object, the object closer to you looks clearer, the object farther. For example, you look at a car at 100 meters away, you can't really see its number plate. Therefore, when you want to display a car 100 meters away in a VR environment, you can go for a coarser system where you can't even read the nameplate. Anyway, it's too far, you can't read it, so there's no point in trying to put a model. So in a VR system, typically what people do, they store object in 3 to 4 resolutions. You see here a statue, the statue is stored in 3 different resolutions with 5,000 triangles, with 2,500 triangles, and 1,250 triangles. So depending on the viewing position of the viewer, depending on the distance of the object in the scene from the eyes of him, they keep switching objects of different resolutions. Farthest object has the lower resolution, nearest object has the higher resolution. This is another smart way of doing the computation faster. Then there is something called view volume culling. When we look at the object, we have infinite objects in the environment, but when we look at it in a particular direction, then we can visualize a conical area. So there's no point in bothering about computing the objects outside this conical area. So you identify the objects that are to be rendered, focus only for these objects. So this looks like a very common sense thing, but it helps a lot in computation. This is known as a view volume culling. Bother about only the objects that are in the viewing area and then ignore all other objects for the particular rendering. Now coming to color rendering, there are thousands of colors you can deal with today. We call it as bit plane. So there could be several bit planes leading to beautiful colors. So thousands of colors are possible. Now, how do you render the color for each pixel? So what they do, they render spheres of different sizes, and then they store color information on the sphere for different light sources. This is pre-computed and stored in the system. Now, when you want to render an actual object like a motorbike, then what is the radius of curvature at different places. For example, this wheel, you can see what is the radius of curvature at different points. Look at the radius of curvature and then choose the sphere that is fitting close to it. And then you also know the radial angle, radial position, pick the pixel in that and then put it here. So by doing it, they are able to do the rendering extremely fast. So you can see objects like this beautifully rendered. So far we were discussing about various techniques to do real-time response. Next, we will see a little bit on stereo rendering. In fact, I'll come to that little later because it's a little more complicated. So we will look at it a little later. Now the third one is multimodal interaction. I told 4 characteristics: real-time, stereo vision, then multimodal interaction, and the fourth one is the intuitive interaction. So when we talk about senses, we have listed 5 of them here. So in the human case, we have eyes, the same thing becomes a camera. And human beings don't have display, but we need display. Okay, so that is why people say, you don't create scene actually. We only receive the scene to our eyes. We look at the scene, we experience the scene. We never create scene. It's a figure of speech. People say if you make any noise or anywhere, they say playwright don't make a scene. So you are not supposed to make a scene. So whereas when we look at a machine, VR system, we need not only to see the scene, we also have to create the scene in the form of a display. So we have cameras as well as displays. Typically, we'll have 2 cameras to create the stereo display. Coming to the sense of sound, in the human system, we have 2, same with cybernetic system, 2, unlike the sense of vision. So we have mouth and we have ears, but there is a slight mismatch of number here. We have only one mouth, whereas there are 2 ears. So the ears are nothing but microphones. Mouth is the speaker. So you will find that in any PC, you will have 2 speakers, which are 2 mouths, whereas the mic will be one only. You need to have stereo sound, you need to have 2 mics also. Okay, whereas in humans side, we have only 1 mouth and 2 ears. Coming to sense of touch, the sense of touch is very complicated. It's far more complicated than the other senses, because on a particular point, it could respond to different stimuli. It can respond to needle, alpine pricking on that. It can respond to somebody slapping. It can respond to heat. Okay, so there are different stimuli. It can respond to vibration. You can see whether something is vibration or not. So it responds to thermal and pressure stimuli. It responds to these happening at different time domain. It could be static, it could be dynamic. In the dynamic environment, I'll come to that a little later, we saw that in sense of vision, the persistence is 8 hertz. That means if a scene is standing in front of you for 125 milliseconds, you will be able to sense it. If it is less than that, you will not be able to sense it. It will come and go, you will not see. That's what happens when the fan rotates. When the fan rotates at very low RPM, then you are able to see the blades. But as the speed increases, you don't see the blade because it is stopping in front of you less than 125 milliseconds. Whereas in the case of sense of touch, it's very interesting. The sense of touch can respond even if somebody touches you just for 1 millisecond. Somebody touches your back for just 1 millisecond, you will be able to sense that. So sense of touch is something very important for VR system, but people are really struggling to implement it. Then coming to the remaining 4 senses, smell and taste. Smell and taste, they so far do not have too much of mechanical engineering applications such as automotive or aerospace, but they will have good applications in biomedical and chemical engineering related applications. People also use it in gaming, okay, but we will not bother about it much here. Now, I will stop our discussions on the other systems like higher senses because we hardly have understood. We talk about heart, we talk about brain, we talk about soul or atma. We really don't know what it is. In my humble opinion, if we are able to model all these senses in a computer system, then we will be able to launch products without even making the prototype. Going one step further, if we understand what is heart, brain, and heart, mind, and soul, then we may be able to even model it in a CAD system, and then you will be able to recreate the human beings like God. Anyway, that's not the topic of current discussion. Now, how do we manage these sensors in the CAD environment? That is by divide and conquer approach. I use the word here, divide and conquer. We divide the sensors for the sake of computing and then understand. You know that all the colors are divided into three basic colors, red, green, and blue. And then by controlling these color percentages, we are able to get variety of colors. So that is a divide and conquer approach. Okay, when you talk about screen, it is RGB. When you talk about multi-jet printing on a paper, there are 4 colors in use. You will see that RGB is an additive process, whereas the other one is process. So what do you mean by additive process? Your screen is black now. Black means no color. So when you put RGB on the screen, you are adding the color components in proportion and you get the different colors. But when you talk about printing on a sheet of paper, you have all the colors there. White is all colors. On that, you are going to subtract some colors and then print. That is achieved in multi-jet printing. That's why you find that the colors are different there, magenta and other. That makes use of subtractive method of printing on a white background. Okay, coming to sense of sound, we know that we have divided into sarigama, pathanisa and things like that. Sense of touch, pressure, heat, I really don't know because people have not yet come up with the details. It's all under various discussion stages. Sense of smell, there is no clear division available, but definitely a sense of taste, we have divided into 6 tastes. We are all aware of it. So we are trying to capture the senses in a computing system by going for a divide and conquer approach. Okay, so now I would like to end this by a summary here. Stereo vision and stereo sound are reasonably easier because stereo sound has a range of 20 to 20 kilohertz. Stereo vision, we are able to manage up to 8 to 25 hertz, whereas sense of smell and taste don't have too much of engineering applications, so we'll not bother so much about it. They do have chemical engineering, biomedical applications as well as gaming, so that's not the focus here. Now, when it comes to sense of touch, it is very, very useful for engineering applications because when you see a steering wheel in your virtual environment, it will be nice if you can also hold it and steer it. Or if you see a lever, it will be nice if you can hold it and move it and the virtual lever moves. Okay, so sense of touch is very useful. Generically, we will use the word haptic. And haptic itself, we can divide it into force sensing and tactile sensing. When I say haptic, I'm talking about only pressure or force. Okay, I'm not yet talking about temperature. That doesn't come under haptic. Okay, because as I said, the same point on the skin can sense not only force, it can also sense pressure, vibration. You feel on a surface, you can say whether it's a rubbery, like soft surface or a hard surface, whether it's a matty surface. In fact, I know a professor in IIT Madras who taught me that fellow takes his nail, rubs on a surface, and then he will say this is RA value 0.5 or 0.3. It is possible because that is nothing but vibration. So by running it on the known surface, he could teach himself. He's a metrology expert. So he could say that people have trained themselves for it. Same with railway, when you walk along the railway wagon, you might have seen at the station, someone walks along it, goes with a hammer. He keeps on hitting the wheel. And then by hearing the sound of it, he says whether there is a crack on it or not. In fact, railway says those people have all retired and now they are running short of people for doing this type of inspection. And a lot of people are trying to capture that knowledge into cybernetic system. They are ready to succeed in that. So tactile sensing has a lot of such applications. I've listed here 4 problems with tactile sensing. One problem is it's highly sensitive. As I said, if somebody touches you for 1 millisecond, you will be able to sense it. That means your computation has to become that fast. I talked about computation. We need to have 50 refreshes for sense of vision. Now, in the case of sense of touch, you need to have 1,000 refreshes, which is computationally very severe. Now, it is too tiny a sensor, but the same sensor has to sense too many things, or in such a narrow place, you have to put too many sensors, something for vibration, something for force, something for temperature, and so on. So it becomes a microelectronic challenge. And the first one becomes a dynamic performance challenge, computational challenge. Third one, as I said, same spots responds more stimuli. And the fourth one is in sense of touch, in sense of sound and sense of vision, you can stimulate it without damaging your eyes or ears. Whereas in sense of touch, you are actually simulating the force. I'll show some photographs to illustrate that. You see that if you want to, suppose you are standing in front of a wall, you want to touch the wall by your hand. The hand has to be prevented from touching. How will you do it? You have to actually put the levers to hold your hand from preventing. So you need to have cameras at the top. They will look at your hand movement, or in this kind of environment, you may have encoders at each joint. The encoder will tell by computation whether your hand is closer to the wall or not. When you are interfering with the wall, obviously you have to feel that there's a wall. So the drive system should pull your hand backwards. So you see here on the right side, 2 pictures. They're all, by looking at it, you feel scared, because what if anything goes wrong? If everything goes wrong, it's fine. When you sometimes reboot, or when you work on it, when the computation is heavy, your cursor doesn't move. Okay, that type of problems are acceptable. Hanging, we say hanging. Okay, when the system hangs, what will happen when you wear it? Suppose it goes to some odd position, you are twisted out of the shape. So this is the problem with haptic rendering. So I listed 4 problems. One is the speed of computation. Second is the space available. Third is multiple stimuli to be set. It's a very dangerous thing to do. So people have even tried putting, tiny pneumatics for the station. It's about various features. I have not talked about one feature. I talked about time rendering. I just hinted upon the stereo vision. We are going to see about the details of it later. I mentioned about the sense of touch and on the difficulties in implementing it. I have not talked about the intuitive interaction, because that will require special interactive devices than our standard keyboard and mouse and the standard screen. So you need something for input, something for output. Your screen is output, your keyboard and mouse are inputs. Okay, so we'll look at them subsequently. Just remember that we have not talked about the interaction. I have, I think, half an hour left, so I'll try to do justice to it. Now I'm going to look at some of the technologies that are required to implement a typical VR or AR system. Whatever I say about VR is equally applicable for AR. In fact, AR is far more demanding than VR, because there's something called registration. By registration, we talk about registering real and virtual objects. See, in a VR system, the definition said, if I turn my head, if nothing changes, it is not VR. So when I turn my head, something should sense it. So there will be a camera at the top. It will sense that I have turned with the vertical axis with respect to some position by 5 degrees. Then the whole scenery should be computed and put it. So that is not with the help of the mouse that I rotate the CAD model. Instead, the camera senses me, and then it tells the viewing point, and then computation happens. So you need that type of sensing. That's what I mean by intuitive. You don't do it, it does it on its own. So now quickly we'll look at some of the technologies used for the remaining part of the time. So these are all the various technologies required to build a VR AR system. Computer graphics, of course, because it's an advanced simulation tool. Then you need technologies for generating stereo displays. It will be ideal if we can get 3D displays, okay, or displays which are 3D, but you don't have to wear anything exclusively to feel it, because very often to get the stereo display, you have to wear some special type of goggles. So I will show you a video where, you know, without wearing any special device, you are able to experience stereo. So that's the second aspect. Computer graphic tools are required. You need, in terms of hardware and software, you need extremely fast graphic processing systems. You need multiple processors and, you know, multiple parallel computing, things like that. Then you have stereo displays or 3D displays. Third is tracking based interaction. That is to get the intuitive feeling. The fourth is you need to have computer peripherals to achieve that, apart from your keyboard and mouse and displays. Then all these should be integrated by incorporating some of the behavioral science. That's where I mentioned it's not enough to have these 4 features of VR. The user also should be amenable to experience in the favorable way. Otherwise, you know, it will go fat. For example, I'll tell you, in Dubai, they built the airport and then they tried to experience. They felt that it was not real. Okay. Then they try to understand how it happened. You know, everything is nicely done. Lights are positioned nicely. Everything is done nice. Then they realize that they forgot to incorporate the shadow. So you may have different lights unless you create the shadow of an object depending on where you look at it. When you walk on an escalator, you need to have the shadow moving depending on the light source, otherwise it's not real. So after they incorporate the shadow, they found that it was far more real. So the behavioral science also plays a major role. Okay, so now we will focus next 10-15 slides on stereo vision. I'm not talking about 3D vision. Stereo vision, how we achieve it. So the devices used for stereo vision, we can divide into 2 groups. One is for single person experiencing and the other is for many persons. It may be 5, 6, or it can be a full auditorium. Okay. So depending on that, we need to choose appropriate devices. So on the left side, I've shown display goggles, head mounted device, boom. Okay, I'll show some photographs of each. On the right side, for multiple people, starting from 2 to 4 to any number, power wall, workbench or virtual table, cave. Okay, I'll try to do some justice by showing some pictures. So this is like a typical auditorium with the screen, and you display something on the screen. When the fellow wears a goggle, then he is able to see the 3D display or stereo vision. If he removes the goggle, what you get is a hazy picture. You don't really have a very clear picture. It will be hazy as if it is out of focus. But when you wear the glass, then the image on the screen is separated and left eye sees what it should see, right eye sees what it should see and not the other way. Then you are able to, your brain is able to assimilate this as a 3D view. So I'll show a small clip. Kindly remember, whatever I'm talking to you, it's almost 20 years old technology. I'm not really updated it much. So bear with me for that. Where is it? I don't know. Okay, I have it here. So this is something I obtained from Fraunhofer Institute in Darmstadt way back in 2002 probably. So 18, 19 years old. But it illustrates a lot of interesting aspects of a VR system. Now you see that the fellow is wearing a goggle. So this is a special type of goggle. You can visualize that this is a goggle where left and right become opaque and transparent, alternate. Okay, on the screen, left image is put first, then right image, and this also keeps happening alternately. So you can visualize that for first 40 milliseconds, left image is appearing. During that time, his left goggle is transparent, right goggle is opaque. So he sees the left image. For the next 40 milliseconds, right goggle is transparent and right image is on the screen. So by alternately presenting the screen alternately every 40 milliseconds and synchronizing the switching of the opaque and transparency on the goggle appropriately, you are able to get a 3D image of the object. So that's what it does. Now, on top of this hall at the roof, you have cameras hanging. You need at least 2 cameras, but very often they put multiple cameras because there are occlusion possible. Some camera may be hidden. Many times you put multiple cameras to carry out a regression analysis so that the errors are removed. Okay, so there minimum you need 2 cameras. There could be many cameras. Similarly, in the markers, he has different objects. He's wearing a goggle, which is one object in the environment. He is holding a stylus in his hand. This is another object. And then you see a stand here on which the object, in this case, an automobile, model of an automobile is sitting. So this is a third object. So the camera at the top has to keep track of all these objects. Now it's not computationally easy to look at the CAD, look at the actual goggle and then interpret it using image processing. That will be very, very expensive computationally. So what they do on each object, they fit markers which are uniquely positioned. Okay, so the camera bothers about only these markers. At the time of calibration, in some particular view, they teach the system that these markers indicate goggle, these markers indicate the stylus, these markers indicate the object, and so on. Okay, this is the calibration part of it. Now, these are all typically IR markers because our system will be sensitive for ambient light. If somebody opens the door and enters the hall, it may be disturbed. Okay, so these are all typically IR markers. So the camera is able to sense as many as 100 markers like this in real time. And then it will tell from that where is the object pointing to, or where is it positioned and oriented. So from this, then you decide what is the viewing part, you decide what is the orientation of the head, where is it, where is he holding the stylus and all that. Okay, so now you see that the video is going on now. So he is trying to do something. This looks, this was shot through one of the goggles, therefore you don't really see it as a 3D, but what, trust me, this fellow is experienced a 3-dimensional view of it. The purpose is to tell you that you need camera hanging at the top and you need several markers to track it. So he has a tablet on his left side. Okay, he touches the different tablets to select the menu. So the tablet also is virtual. What he holds on the hand, left hand, is nothing but a transparent plate, but it is calibrated and all the menus are fed into it. So he's able to nicely draw in 3D. Now this is power wall, where you have one vertical screen and then you work on it. There is another very interesting device called workbench. In workbench, the display becomes horizontal like this. This is an old type of display where they had a screen and they put a 45 degrees mirror and then projector came like that. But today you can directly put your LCD or LED monitor horizontally. Originally it came for surgery planning, because during surgery the patient is unconscious and lying. So they decided to have the table horizontal. That was the initial idea, but subsequently it became more useful for multiple people viewing, with each one having his own viewing directions. So this also became useful for other applications. So this is a video related to that. You can see that when you have it like that, you can put your car model directly on the screen. It is as if it is standing on the wheels. So he can keep it there, he can lift it, turn it, the markers are kept track. He draws something in space that appears as the object on the screen. So he is able to draw the bonnet, he is able to draw the windshield, top and all that. So this is how it happens. So I'll move forward. I have maybe about 15-17 minutes available. Okay, so in both these cases that you saw, there was only one screen. Okay, one rectangular screen in which we had to do the visualization. Subsequently, people thought, why not surround the user with multiple screens? Okay, so that is how cave came into picture. So cave also looks like a cave. You're going into the cave, but the actual expansion is different. Okay, so you have multiple back projection screens, and all the walls are made out of glass. So the glass is more than 1 inch thickness. So they project different screens on different projectors project different scenes on the different screens appropriately. So when you are inside, you feel that you are surrounded by the scene. So you remember the feeling of inclusion, which leads to feeling of immersion. So to enable that, they have added as many as 6 walls surrounding it. So the word cave also sounds appropriate. This is very much in use today. A lot of people use it for very serious simulation applications, such as flight simulation. Okay, this is a cave in operation. We'll move on. Now I am come to some example of single person viewing. One is a head mounted display. So here in front of him, there are 2 CRTs. In the old days, small TV CRTs, and then they used to put left image to left eye and right image to right eye, and he was able to see it. Obviously, he was not able to see anything else. Only virtual objects were available to him. Then he had some interactive device. You see already that the mouse is not the traditional mouse. This is a 3D mouse. So like that, you need to go for equipment or interactive devices that are amenable to enable you an intuitive interaction. So this is also a head-mounted device. So it was based on CRT, so it was pretty heavy. So you wear something which is about 7-8 kilo heavy, you can't definitely wear it continuously for more than 10 minutes. You feel compressed rather than immersed into the system. Therefore, people thought, why to carry such a heavy device? Put it on a stand and then view it. That is how this boom came into picture. Boom stands for binocular omni-oriented monitor, but it also refers to this boom. But very soon this became obsolete because CRT was replaced by LCD and LED displays. Now here you have a very interesting system where the CRTs are on both ends, on the sides of the person, and he is wearing a goggle, which is totally a transparent goggle. At the center of the goggle, there is a 45-degree prism. So when the scene comes from the CRT, the prism will turn at 90 degrees and he gets. So the virtual image is on the CRT and he is able to also look at the real object. So this is one of the early examples of augmented reality. What is augmented reality? In augmented reality, you merge physical and virtual information together. Okay, so in this particular case, they use this device for the pilots. So the pilots were wearing such a device, and the commander in the ground station. Now, please remember that this is not a very highly sophisticated system. It could be as simple as a single display, not necessarily a stereo display, because typically when the pilot wants to bomb an enemy territory, this will be the first time he would fly over there. So prior to that, drones or unmanned vehicles, aerial vehicles, go and do the reconnaissance mission. They take, they shoot with overlapped GPS positions and other information like height information. So the ground commander will have the data with them. Now the fighter pilot will fly. So as he flies over the territory, he sees the physical territory, and the ground commander will also project the image appropriately manipulated to match with that. So the commander sitting there can point out, this is the building you have to bomb. So he can use an arrow to say that is the building you have to bomb. Then the pilot will be able to shoot it. So this is a beautiful application of virtual and augmented reality, where the virtual and real information are merged together to solve the mission requirement. There are also different types of displays coming up, with a lot of miniaturization taking place. We have very simple displays coming today. Today we also have displays where the laser, very fine, low power laser, can write on the retina and then create the information. You don't need a CRT or any kind of display, and you can directly write on the retina of the eye. Okay, now little more details about the display. There are two types of stereo displays possible. Stereo means two. So the two images corresponding to the left and right eye can be simultaneously dumped on the screen, as in this case. In this case, the images of left and right eye are simultaneously dumped on the screen, and they are in different color frequencies. So by wearing a goggle with different colors, you will be able to filter out, and the left image will go to the left eye, right image will go to the right eye. You will see that every object is an offset condition. Okay, so they are in different colors so that they are nicely filtered and sent to the appropriate eye. So this is very suitable for mass application. All the movies, 3D movies, they make use of this type of color filter. They are very cheap. For 10 rupees, you can make it and you can throw it out. Okay, in exhibitions and various places, they use this type of thing. This is for simultaneous projection, but unfortunately, this has very few color options. So subsequently, they have developed a system using polarized glasses where the polarizing direction is at 45 degrees or 135 degrees. So for left eye, it is 45, right eye 135, or vice versa. There's another method which is known as, this is linear polarization. One could also think of circular polarization. So just imagine that polarized glasses can be used for simultaneous projection. When you say simultaneously projecting left and right image, then your computation can be faster. On the other hand, the most popular displays make use of alternately projecting for first, let's say 40 milliseconds left image, next 40 milliseconds right image. I already explained about that. And you have a goggle like this, which keeps on alternating. And here you have a sensor, which, in most of the VR system, you might have seen near the CRT, a box like this. It is like our TV's remote box, which is emitting frequency, which synchronizes this frequency so that the changeover on the screen is synchronized with the changeover on the opaque and transparent regions. So this is a system of alternate projection. So we have seen reasonably about the stereo display. Now I'm going to show you a very shocking mechanism. In all stereo vision, you need to wear some goggle. Now this fellow has come up with a method by which there is no goggle. So first I will play the video. I'm very sure none of you would have seen it so far. I don't know. If somebody has seen it, I salute him.
Audio is not there.
Okay. Audio is not coming. Am I supposed to switch on anything in your system? Otherwise, what I'll do.
Share the computer on this.
Now also not coming?
No, sir.
Okay. Okay, what I'll do, I will explain. It's not a problem. What you see is important. I will explain. It doesn't matter. I'll explain that. But my voice is clear, right? Yeah.
Yes, sir.
Yeah.
Yes.
Okay. So they have developed a hammer-like device and they put on the temples. Okay, so imagine that some pin is pricking on the left temple, immediately left eye will close. If you prick on the right side, right eye will close. Or you hit on that, that is a stimulus he gives. So you'll see it. Don't bother about the voice. So it just hammers. When right is hammered, right eye closes automatically. That is our reaction. So when it is like, imagine that the device is not available. You wink your left and right eye. I know the goggle, what does it do? It keeps your scene open for left for 40 milliseconds, right for 40 milliseconds. So if we are able to wink at that kind of speed, then you will get stereo vision. You don't need the goggle. Unfortunately, we cannot do it ourselves. So what this guy has done, he has developed a hammering device, and this hammer, it hammers alternately on your temples. Okay, so every time a hammer happens, you immediately involuntarily close that particular eye. So when this happens alternately, he is able to get a very fast winking, alternate winking, not normal winking, but alternate winking. Let's not immediately bother about what will happen to the eyes, and all that. That is for the researcher to further, prove it. Maybe it will damage the eyes or not, but what we have to look at it is the innovation somebody has come up with. This is called out of the box thinking. I could never imagine that somebody could develop a device which doesn't require a goggle. Okay, so it is a detailed investigation which will decide whether it is good or not. The fact that it's not yet popular means that it is still undergoing testing. Okay, so now I have listed once again the same slide. These are the 4 features: real-time response, stereo or display 3D rendering, intuitive or spontaneous and effortless interaction, multimodal interaction. We have seen the first 3, but we have not seen the third one. So I'll spend another, maybe we have just 3 minutes or 5 minutes left. I'll try to complete it quickly. I want to now talk about intuitive or spontaneous interaction. It will go very fast. We have already looked at it to some extent. Now, this is a test called Buxton test. Okay, he asked people in an audience, draw a computer. Okay, all of them drew only this. But this is really not computer. This is only the interface, keyboard, mouse pad also he has drawn. He has drawn the monitor, but he has not drawn the CPU. The CPU is the computer. So we perceive the object through what we interact with. That is the meaning of it. That means the interaction has to be very efficient. So that is the point he is trying to make. So I'll quickly show some of the devices. This I have already shown. This is a haptic based feedback device. And here you have a globe. This is an electromagnetic globe. So it will be able to sense your hand position. So if you want to grab an object, it can sense a hand position and then tell. So you have various types of sensors in use. Electromagnetic, this is electromagnetic. Ultrasonic sensors are possible. Optical sensors are possible. These are all mechanical sensors, master-slave type of control. So mechanical sensors are possible. Even more features can be added to this. A lot of things are happening here. So here you see that a lot of electromagnetic sensors are there. They have a junction, they have a cable. The most important advantage of ultrasonic and optical sensor is it's a cable-free arrangement. Otherwise, the contact type sensors are far more efficient in terms of accuracy. So similarly, you have several styluses available. You use stylus. Our writing on a Wacom display is a typical stylus we have. But here we are talking about optical stylus also. So here you have a virtual torch. Okay, it's not really a regular torch, but a virtual torch. It is as if you are walking into the Ajanta Ellora caves. You take the virtual torch. When you light it, you are able to see the light falling on the stage. Everything is virtual. So you could also achieve it using the mouse and keyboard. Then you are conscious. But when you want to experience how you are moving in a cave and seeing various statues or paintings, then you have a virtual torch. So, for instance, like that. Now, a few words about augmented reality. I will not spend much time at all. So, as we saw, it is the mixing of virtual and real object. Both objects need not be 3D in nature. For example, what you see here is a physical panel, and then the knob, the red color part of the knob, it is the virtual thing. So in virtual and real matching, registration is very, very important. See, when you talk about turning the head, sensing it by the camera, it will not be accurate, but it doesn't matter. Okay, but augmented reality, you need markers. These are all the markers put on the panel. I'll show you a very important application which will explain it. Explain the importance very well. So this is brain surgery application of augmented reality. So what they do, they bald the area and then they pen which will respond to the imaging system. So while typically the brain tumor is sensed using MRI scan. So this ink will also be sensitive to MRI scan. So when they scan it, they get the CAD model in 3D of the brain tumor, all interior substances, as well as the grid of the marking. The quality of marking may not be good, but whatever you draw, it will be captured as it is. So now when the doctor opens up the skull, or he uses an endoscope to go into it instead of cutting open, then he will be able to see not only the real head but also the projected image on it. Many times he doesn't even see the real head. He will look at the projected image on a VR screen, and then he will use a robotic scalpel and operate it. So in this case, the registration accuracy, you'll appreciate that the registration of the physical grid and the virtual grid have to exactly match within 0.1 millimeter, let's say. Then, your accuracy of scrapping away the tumor is much better. Because otherwise, either doctors leave away some tumor in the past, because if they scrap away the brain, then they could disable some of the functionalities. So today, the precision of tumor removal is substantially higher when you go for this type of augmented reality application. Accordingly, this application explains very well the benefit of augmented reality, as well as the importance of the accuracy of the registration. So in virtual reality, you don't use markers, use simple cameras. In augmented reality, of course, in virtual reality, the markers used are those spherical balls, like very rough markers. Whereas here, the markers are far more accurate. Okay, so for the benefit of time, I'll skip. I'll come to the conclusion slide. So I have told you 4 important features: real-time response, photorealistic stereo or 3D rendering, multimodal interactions where you think of multiple sensors in use, then using special IO devices for intuitive interaction. So when we have these 4 features for a VR system, that will give you the feeling of immersion. But as I said again, I'll emphasize the user also should be amenable and receptive for the experience. So he should also cooperate with the environment. So VR is a multimodal environment for simulation. Immersive feeling enables more realistic evaluation of design. It is effectively used by aerospace and automotive industries today. Wargaming, pilot training, surgery planning, so many things have been possible. In fact, the wargaming is very, very important, and flight simulation, when ADA made their aircraft, they trained the pilot on a flight simulator, which is a parallel kinematic system called Stewart platform, and then they train him. Then finally they put him at the cockpit. There is a tank simulator in Avadi, Chennai, in a DRDO organization, where they're able to simulate the tank. I and my daughter once sat in it and experienced a tank running into the desert, the tank running into water, the tank running into the forest. It's a very realistic feeling, because surrounding you, you have a screen, and at the bottom you have a Stewart platform. So you see the scene, and the Stewart platform rocks you to give you the feeling. You even feel giddy, as if, in some of the rough travels, you feel vomiting. You get even that type of sensation. Okay, so stereo vision or 3D vision using a single 2D surface is not adequate, but today only that is happening. So we need to have real 3D displays. One of the possible things is our there are several 3D displays coming in, but nothing is really available in a commercial way. Input and output of other senses than vision and sound have a long way to go. I listed 4 problems with the sense of touch during the lecture. AR is mixing of real and visual objects. Registration is very, very critical in AR than VR. So with these simple concluding remarks, let me stop my lecture. So it's open for any queries. I'll stop sharing so that I can look at the chat box. If there are some queries in the chat box, I'll see. Are there queries? Professor Sunil, did you see any queries?
So first question was, you already answered the question during your talk, sir.
Okay.
Commercialization of your project.
Okay, that's for drone.
Yes,
for
sir.
drone, is it okay? I'm looking for a lot of enthusiasts who can, collaborate with us.
Yes, sir. And second question was, can they visit your lab? I mean,
Yes, of course. IIT is not a defense organization. Anytime they can come. Off late, because of Corona, we were strict, but we started opening. But yesterday, my student said, again, it is coming up.
Yes.
But otherwise, I am very, very open. Voice is breaking. Someone is talking, but it's breaking. Can you repeat again?
Today, yaar KLE mechanical. Please ask them to mute.
Yeah, please ask. Someone was asking, I thought.
No, sir, no.
Okay, so in terms of visiting the lab or seeing the facility, it is never a problem. Feel free to come. Even if I'm not there, I've instructed my students to show it. Except some of the industrial projects where they have given money, we will be able to share most of the information. Especially drone, I want people to jump on it.
ಸರ್ ನಮಸ್ಕಾರ, ನನ್ನ ಹೆಸರು ಪ್ರಸಾದ್ ಅಂತ, ನಾನು ಬೆಂಗಳೂರಿಂದ ಮಾತಾಡ್ತಿರೋದು. ನಿಮ್ಮಲ್ಲಿ ಟೆಕ್ನಾಲಜಿ ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡ್ತೀರಾ? ನಿಮ್ಮ ರಿಸರ್ಚ್ ಮಾಡ್ತಿರೋದ್ರಲ್ಲಿ ನಾನು ಇಲ್ಲಿ ಎಂಟರ್ಪ್ರಿನರ್, ನನಗೆ ಆಸಕ್ತಿ ಇದೆ ಈ AR ಮತ್ತೆ VR ನಲ್ಲಿ ಏನಾದ್ರೂ ಪ್ರಾಡಕ್ಟ್ಸ್ ನ ಡೆವಲಪ್ ಮಾಡಬೇಕು.
I have understood whatever Kannada you have told.
Okay, no, I will talk in Kannada. I will speak in English.
No, it's okay. I have understood it, but I'll reply in English. I'm a teacher in augmented and virtual reality. I have not done any research and I don't have a product. But I'm basically a manufacturing engineer, automation guy, computer graphics and all that. So if you have a product in mind, we can work with you and then develop it. But as of now, I have no product in this area, but I have products in 3D printing area. There are at least 4 products we have uploaded for commercialization.
Okay.
So which one you are interested? You are interested in virtual reality, is it?
In virtual reality, whatever you have shown for medical, especially for those operations, they are very excellent.
Yeah, but whatever I have shown, it is all literature material. It's not my own research.
No, we have to develop that. So
we will develop. If what we see, identifying the product is very, very important. If we wrongly identify a product, you will not find a market. So people in the field like you, if you identify a need for a system, many things may be existing. We can help you in buying it out directly, or we can develop it together. We are in a disease. Mainly, a lot of coding is involved. A lot of hardware are available today readily. So if you, and IIT has a wonderful group of students, we can make use of them. My job will be more of facilitation rather than doing it myself.
Say building simulators for these type of operations will really help the doctors.
Yeah.
Some, in the education itself, they can learn many things. So that is one thing. Secondly, for engineers also.
But my request is look at the medical application last, because even if you develop, making them accept, human life is involved. It's so we are low hanging fruit first. Whichever we can quickly implement better. Then I don't know. I leave it to you if you are very closely in. See, if the doctors are already using a VR application which is imported, then probably indigenization through, you call it as reverse engineering or inspiring, it doesn't matter. Okay, see, we were looted by the foreigners for so many decades. So as long as you are legally right in reproducing it, it's okay. Legal rightness is one thing, ethical rightness is another thing. I'm not worried about the ethical rightness because even now the Kohinoor diamond is in London. It has no business to be in London after they left the country. So copying or reverse engineering or inspiring is nothing wrong, but we have to be very clear that we don't violate it legally. If they have filed a patent and protected the IP, we have to be careful. And there are ways of even overcoming that. You are not going to blindly copy. You are going to add your own ideas. So you will be able to bypass it. So let us, you identify a nice product, then we can all work together as a partner rather than as a vendor and then develop it.
Thank you, sir. Please share your email ID and contact details.
Yes,
I'll do that. I'll do that.
I will share again and go to the last slide where I have my contact details. Yeah, you can shoot it. Sorry. Yeah. Shall I stop it?
Yes, sir.
Yeah.
Thank you very much.
So this is what I meant by networking. I'm not you are not the beneficiary alone. No, I'm also a beneficiary. It's a bidirectional networking.
So participants, any other questions?
Sir, there is one more question in the chat box.
So my request is, a drone has flown only 2 feet. Don't be disappointed by that. Right now the possibility is important. Our safety is important because we are made out of stainless steel structure. We want to test it at this height several times, look for cracks, bendings and other problems. Then only we can take it high. We all have to live, in order to test it further.
Yeah.
Many people, novices, they quickly comment, "Arey, what is there? It has just taken off only 1 foot, 2 foot." But this has technically proven that it is strong enough and light enough.
Yeah, Professor Sangoli, I think
Yes.
If there are any questions, they will. They can contact Professor Karnakaran through mail or any other.
Yes, sir. Yes, sir.
So, Professor Pasavaraj and others, let us interact more. And
Yes,
sir,
now flights
we
are
look
working, so we can visit also each other.
Yes, sir. Yes, sir.
Yeah.
We'll take it forward. We'll see that we'll have certain occasions for academic initiatives, collaborative programs, wherein we request you to come out to our campus, visit us, depending on your time availability. Sir, good presentation, and I will not comment on the technical part of it. Very interesting.
Thank you. In fact, you spent all the time, that's my honor.
Yeah, I'm
the
there.
Principal sitting throughout, it's not easy.
I'm there, sir.
Yeah.
Thank you very much.
Thank you very much.
Sir Sunil.
Thank you.
Yeah.
Thank you, sir. Thank you.
Yes, yes.
So participants will be back for a lecture by Prasad Omkar from IIT Hyderabad at 2 o'clock. Thank you very much. Thank you, Karnakaran, sir. Thank you very much.
Thank you,
Thank
Professor.
you. Thank you. Bye-bye. Good luck to all of you.
Thank you, sir. Okay. I will leave it now, Professor
Yes, sir.
Sangoli.
Yes, sir. Please.
Yes, sir.
Okay. Carry on.